Y'all let me know if y'all can hear me. Microphone check. 1 2 1 2. Gotta give me a second here. Damn. There I go. What it do, family? Appreciate y'all for tuning in. Shout out S Smooth in the chat. You are now tuned into the network. The network. Bruh. I swear I gotta get me a new phone, man. I also have an iPhone, which works way better than this old ass Android that I got. And I was trying to play some music today on the basketball court. The bitch died because it was too hot out there. That's how hot it was. It was like temperature is too hot, shutting down. Bruh. I guess that's how it is. But anyways, like I said, you are now tuned into the network, bro. Today's lab is Lacp, PAgP, and multiple STP. What is all of that shit, right? Lacp and PAgP are two standards for creating they're two standard protocols for port channels. You're probably wondering why the hell I got a bonnet on too, huh? Yeah, so I've been growing my hair out and stuff, man. Oh, you got S-Smooth. All right, appreciate it. You loud and clear. Good to go. So yeah, I've been growing my hair out and stuff like that, and I've been not wanting to mess up my curls, and I've been getting twists and stuff like that, and don't want to mess it up. I don't want to put a do-rag on because it compresses it and stuff like that. You know, do-rags for more like waves and stuff. So I've been wearing these bonnets, and you know, there's just been just controversy about people wearing their bonnets in public and stuff like that. So in light of that, I decided to wear my bonnet on this live stream. So for any of my, you know, African American viewers in here that know about this struggle, y'all know what it is. But if you don't, now you do know. So anyways, like I was saying, geez, I hate this fucking app. Sorry. So yeah, port channels are a way to bundle a link and make it into one logical port channel. So for example, we have, and I'm pretty sure if you're watching this, you probably know what it is, but just for any of the newbies in here, right? So we got this link right here, for example, that link, and then that link, right? So we got two physical cables going like this, right? But we can put these together in what's called a port channel, right? And there's two types of standards. There's LACP and there's PAgP. One is Cisco proprietary, and the other one is open standard, meaning you can use it with any vendor, right? So Juniper, Arista, whatever other brand, right? Now, and when you, like, again, so these physical links combine to be joined to make one logical port channel. So even those two cables, and also when we do this, we kind of like not necessarily double our bandwidth, but like let's say we have a yeah, so this is one link here and then one link here. Together they make one link, right? So that's one port channel. And again, we have two types of there's two standards, LACP and PAgP. Pop quiz. Which one is a Cisco proprietary one? I'm pretty sure y'all know it. If not, go ahead and put it in the chat. You know, I'm pretty sure we got some smart people in the chat room. So if I can't answer your question and stuff like that, we got some smart people in the chat room there. Go ahead if you have GNS3 or EVNG. Go ahead and cable up 4 switches. I'm gonna give y'all a couple minutes, and also we have sometimes some people that, you know, tune in to the stream kind of late, so that'll give them some time to catch up too. So we have one distribution layer switch here, one distribution layer switch there, and 2 access layer switches, right? And then cable them up like that, with all, just like this, right? So your interfaces might be different. I'm using physical hardware. Y'all know how I am a proponent of using physical hardware as opposed to, you know, virtualization. I know that it's a lot more convenient and it's quicker to spin up labs and stuff like that. And if you want to start up a new one and you ain't got to reload like I do or change up the cabling and shit like that. But y'all know how I am. I'm old school, man. Probably older than half my viewers in here, but it's all good though. So again, go ahead and cable them up just like that, back to back, right? I'll give y'all some time to do that. I already reloaded these guys. I did a little run here. So there's some things that was there any? So yeah, I learned a couple new things on this lab. Also, what else did I not talk about? Multiple spanning tree, right? So multiple spanning tree is a way to group instances of spanning tree, right? Remember how we had in the last stream, we covered, what did we cover? We did just, I think we did rapid PVST, right? So we had, like, let's say, remember we had the route for, we had specific routes for specific VLANs, right? So let's say, for example, we had, I don't know, VLAN 100 on all these guys, on all these switches, right? But the route we made, like say we made this switch right here, the route for VLAN 100, right? Remember what we said about the route bridge, right? All of the traffic must pass through the route bridge before it goes out to the internet, right? This is kind of like the center of the network. So again, I'll draw the little internet right here, right? And there's an ugly little cloud right there. Looks like Cloud Guy. I'll even give him shoes just like in the movie Trolls for all my parents in here. He got some shoes just like that right there, right? That's the cloud. Before we go into the internet, right, we have our laptop right here. I'll try to be a little bit better with the laptop. Y'all know I like drawing and stuff like that. Plus, I'm giving a little people some time to cable up their hardware, their devices and stuff like that. We have our laptop connected right here. And before he goes out to the internet, right, when he sends traffic, he must go to the route bridge first before he exit out to go to the internet. We can set different route bridges and stuff like that, right? Now, multiple spanning tree, we have different instances of spanning tree, but we group them together. So we can have VLAN, let's say we have VLANs 1 through, I don't know, 1 through 1,000 on this switch. On all of them, right? On all of them, right? But we can group all of these to be in one instance, and then we can make, let's say, I don't know, this be the route bridge for one specific instance. Let's say we have instance 1, or I don't know, instance 1 is 1 through 100, right? And we can have, like, say, I don't know, instance 2 will be like VLANs, I don't know, let's say 1500, or yeah, 1500 through 1505. I don't know. I know I got some sloppy handwriting in here, but just bear with me, right? And that's instance 2, right? And we had that on all these switches, right? We can have this be the route bridge for one instance, this be the route bridge for one instance, and it's kind of like, it's a way of optimizing our network, right? So I don't want to get too deep into that. We're going to do some more labs on multiple spanning tree. I know I definitely need a review with multiple spanning tree. We go back to our, come on, buddy. We go back to our study sheet, right? And in case you guys don't have a copy of this study sheet, join my Discord server and I'll share it with you, right? So this is kind of like a study sheet that I'm using right here. Today's lab that we're going to be doing is going to be from the 101 Labs Cisco CCNP book, which you can get from 101labs.net or on Amazon, right? And there's also a link in the description of this video here as well. We're going to cover, again, Lab 3. This guy right there, LACP. And then maybe throughout the week, I'll probably do some Boson NetSim labs. I do have the new version of it. I want to do a giveaway once I reach, where we at right now? Yeah, I say once we're at 5,000 subscribers. I'm getting some promotional copies from Boson NetSim. They actually give me some that I can use for personal use, but I want to give some away for a giveaway. What else we want to do? I want to probably do an MST lab from this book as well. So we're going to be focusing on this week. This line right here. This line item, right? Chapters 2 through 4 from the official cert guide. Some CBT nuggets, some YouTube videos, etc., etc., etc. So join my Discord server and I can share this with you. I will put a link in the description or a link in the chat for the Discord server, and then we'll get started. Discord server. I know I look funny with my damn my bonnet and stuff like that. Man, I can't just take this guy seriously, man. What the hell? He over here streaming with his damn bonnet on. Yeah, well, I don't have any protective hairstyles right now, and I want to, protect these curls. So that's the Discord server. Join that, and you can get a copy of the study sheet. I'm gonna go ahead and get started. Again, I hope you guys got started as well. I gave you 10 minutes while I was talking shit and gave you a little intro here. So again, DLS1, DLS2, ALS1, ALS2. Cable them up just like this in this topology here. Task number 1 for this lab. The focus of this lab is to understand EtherChannel, LACP, and PAgP, which we just discussed, and multiple spanning tree. I don't think I discussed that in full detail, but that's what the damn study guide is for. Maybe I'll try to do a little bit more, a deeper explanation before we jump into the next lab, maybe tomorrow or something. But task 1 is to disable VTP on all switches. We only got, how many tasks we got today? We got 6 tasks. So let's try to knock this out. Disable VTP on all switches. We did this VTP in like the past, I don't know, maybe 4 or 5 streams, right? No, definitely the last stream. The last 2 streams, I think we did VTP, right? VLAN trunking protocol. So like if we had created, I don't know, VLAN 500 on this switch, right? And we made this guy a VTP server, let's say 500 through 600, right? And we had 100 VLANs, right? Instead of doing 100 VLANs on the rest of these guys, right? We can put them on this guy. As long as these guys are all in the same VTP domain, we can have those VLANs propagate on all 4 switches, right? They want us to turn that feature off. I don't know why. This is what Paul Browning asked us to do. So let's go ahead and do that. Remember, there's 4 ways or 4 modes that VTPs can be in, or a switch that's capable of VTP can be in. It can be a server where you can create, modify, and delete VLANs. It can be in client mode where you can just receive VLANs and stuff like that. You can't create them, you can't delete them, but you can receive them from the server. You can also do transparent mode where you can create, modify, and delete, but they stay locally within your switch. Or you can turn it off completely with VTP mode off. Now, I already looked at the solution guide for this book. He said, I'm not even gonna say, but this is what I'm gonna do. I'm gonna turn it off completely with the mode off. So we go to switch 1. Actually, I need to change the host names. DLS1, DLS2, ALS1, and ALS2. Right? Let's do that. So host name, he is DLS1. Let me know if y'all got any questions or anything like that. Y'all hit me with that like button. Run me with my likes. Run me with my likes, man. I seen the last couple streams. I'm like, man, all these people watching and nobody hit me with that like button, man. I need to be like these YouTubers that just, before you get started, please hit me with that like button. And that share button. And the subscribe button. Because I have a goal. His host name is DLS2. DLS2. And then he's going to be, switch 3 is going to be ALS2. And then that's going to be ALS1. Because I cable them up differently here. So maybe your interfaces and your switches might be different. So bear with me. VTP. I'm sorry. What was I doing? Host name. ALS. He is ALS2. And then third guy, this fourth guy, he's going to be ALS. That's going to be this guy. ALS1. That's ALS1. Right? Let me know if y'all have any questions or anything, man. I definitely need to do a review with MST. I'm gonna go hard in the paint this week with MST, man, because I forgot about that. I didn't forget about that spanning tree flavor, but it's one I haven't really touched since like when I was first studying for CCNP and stuff, man. ALS2, right? Yes. No, he's 1. He's 1, and the second guy was 2. Yes. And what was I at? We're going to turn off VTP on all these guys, right? We say VTP mode. Now, question mark, you'll see. You can do, just like I mentioned, you can do client mode, server mode, transparent mode, where they stay within locally, or off. Now, this is one feature that's, I don't think that's on every iOS. The newer iOSs have this off feature. Back in the day, it used to be just client, server, and transparent. That's why I think he said, I think his solution is different. But I'm going to go with off, right? So VTP mode off. And I'll just go ahead and copy and paste that bad boy. Switch 2, VTP mode off. Same thing with this guy, VTP mode off. And notice we get the little message there to let us know VTP mode, setting device to VTP mode off for VLANs. We verify that with what? Show VTP status. That lets us know VTP mode is off. But we also got that little syslog message that let us know, right? So now we're not going to be, we have to manually create these VLANs and they won't be passed on or shared or anything like that, right? All switches should support the configuration, modification, and deletion of VLANs. So, again, these features that I was just mentioning. Off, you can do, believe it or not, you can create, modify, and delete VLANs. Server, you can do that same thing as well. Transparent, you can do it as well. They just stay within you locally. Client, you can't delete, modify, or configure VLANs. So, that's what he means by that. That was task 1, so we're done with that. We only got 6 tasks to go. I mean, not 6 tasks, 5 tasks to go left, right? So task 2, configure EtherChannel trunks on the switches illustrated in topology. So all these interfaces here, it's gonna be a lot of work right here, right? They want us to put this in a trunk, this in a trunk, this in a trunk, all these guys, right? Let's go ahead and put that in the trunk, 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 all of them. All of them. I don't know. I'm not going to count them. Let's just do them. Y'all know how to do trunks, right? If not, then just follow along. Y'all know what a trunk is, right? What's the difference between a trunk and an access port? Trunk carries all of the VLANs, right? Access ports carries only one VLAN at a time. Y'all any questions or anything so far? Y'all been kind of quiet. Let me refresh, man, because last time I did that, I was like, yeah, nobody say nothing until I reloaded, and I was like, a whole bunch of chats just smacked me in the face. Reload, and yeah, y'all just quiet. It's all good, man. Y'all paying attention, I guess. Y'all want to move that like button, though. All right, so I'm gonna start off with on DLS1. On DLS1 here, and then I'm gonna just go one at a time. Do these interfaces. Actually, we only got to do one at a time because we can do their numerical order, right? 7, 8, 9, 10. And hit 11 and 12. So we can do all of those. We can do a range and put them all in trunks, right? And to be honest with you, by default, it should already have these guys negotiate. So as soon as I do this side right here, the rest of these guys should start trunking, right? And we can verify that, right? Let's go to DLS2 real quick. See who's trunking, right? Who has the most? Yeah, DLS2, right? We'll go to DLS2 and see who's trunking, right? How do we do that? Show interfaces trunk, right? Show interfaces trunk. Nobody's trunking, right? So let's go to DLS1 and do a range 7 through 12, right? Interface range, FAST. Your interfaces might be different, right? 107 through 12, switchboard. And also I have to do the encapsulation of mine because I have an older version of iOS. Not really older, but just, yeah, pretty much an older one. It's not XE or whatever. So switchboard, trunk, encapsulation, .1Q. Now, if you got iOS XE, you ain't got to do this right here, right? Because back in the day, they had two types of encapsulation, .1Q and ISL. I'll show you. I know I've explained this a million times, but sometimes I explain it a million times. It helps me remember it. So, right here, we got .1Q as one type of encapsulation, and also ISL. You can also negotiate, but we don't want to do that right now. We're just going to do .1Q. And I think it'll negotiate anyway, so .1Q, right? Then we say switchboard mode trunk. That hard codes it as a trunk, right? They should bring it all down, bring it back up, just like that, right? So now, theoretically, being that we didn't touch this guy, by default, it's in dynamic, I think dynamic auto or negotiation. So this should be trunking. This should be, matter of fact, all these motherfuckers should be trunking. Excuse my language, but y'all know how I do on this channel, man. I keep it funny. So let's go to DLS2. Show interfaces trunk. Trunk, if I know how to spell, right? And now we're trunking on 11 and 12. What happened to the other guys? Oh, you know why? Not all of them, because here's why, right? Only these guys are connected to it. We got to manually do those guys right there. And then they should theoretically negotiate with the rest of those. So I got to go to DLS2. So I'll show y'all real quick, right? Notice right here, we have 11 and 12 trunking, right? How do we do that? Why? I'll explain it real quick in case somebody doesn't understand or didn't see that. I made these guys all trunk with the interface range command, right? But it's probably only made this trunk, I'm sorry. Yeah, pretty much. The only ones that trunked on this one is this and that, right? On here. These guys aren't trunking. Why? Because we have to manually do it either on this side or on that side. Then the rest of these will be trunking. So right now, these guys are not trunking. These guys are. Y'all see that? That's why 11 and 12 right here. 11 and 12 is trunking because we did that side. So that's what this N right here means. It negotiated to become a trunk. Y'all with me so far? Got any questions? I'm kind of quiet tonight. Don't leave me by myself here in my bonnet right here. So let's see what we want to do. Let's go ahead and manually make these guys a trunk, and then theoretically the rest of these should be trunking. These right here should be trunking as well. So 9 through 8. Let's hard code those as a trunk. Interface range. I'm sorry, 9 through 8. What the fuck? 7, 8, 9, and 10. So 7 through 10. FAST 10. 7 through 10. Switchboard mode trunk. See, we got to do the encapsulation here. That's why I got this error right here. In interface whose trunk encapsulation is auto, right now set to auto, cannot be configured in trunk mode. So we got to do the encapsulation first, right? Switchboard, trunk, encapsulation, .1Q. Then we do hard code as a trunk, switchboard mode trunk. Again, if you have iOS XE or newer version of iOS, you ain't got to do all this because they got rid of all that shit. So now we do show interfaces trunk. Theoretically, the whole switch should be trunking. At least all the ones that are plugged up, right? Yes. So 7, 8, 9, 10, 11, 12, right there. 7, 8, 9, 10, 11, 12. All these guys right here are now trunking. So theoretically, these guys should all be negotiated also as a trunk. We'll just pick one and then move on. So let's go to ALS2 and see who's trunking. We should have 4 interfaces trunking. ALS2, show interfaces trunk. I know this is the easy part here. Y'all run me with my lights, man. Run me with my lights. Or subscribe if you don't know. 7, 8, 9, 10. All right, so we should be good to go, right? What else we got? So we configured. Now you say configure EtherChannel trunks. Only switches DLS1 and DLS2 should actively initiate channel establishments. Switches ALS1 and ALS2 should be configured as passive links, right? So these guys should be configured as passive links. So I'll give him a little sad face. He's just a passive kind of guy. He is going to be passive, right? Sad, so he's passive, right? So we'll make these guys passive. And then he said, only switches ALS1 and ALS2 should be configured as passive links. And DLS1 and DLS2 should actively initiate channel establishment. So we'll make these guys kind of like aggressive to become port channels, right? And they'll explain where they want these port channels to be. So please note, depending on your switch model, you may have to choose between ISL and .1Q encapsulation manually, which I just showed y'all, as we do in the solution. The EtherChannel should be configured as follows. Y'all remember what I said at the beginning of this video, right? What's the EtherChannel? We put physical links, combine them into one, and that is considered. We bundle them into one. That's considered a port channel, right? So, for example, this line right here, that's one link, that's one cable going to that, that's one cable going to that, right? We put these guys together, and that becomes a port channel, right? That's an ugly oval. They become one port channel, right? Now he said the 2 ports between DLS1 and DLS2, which is this right here, this right here, and this right here, belong to channel group 1 and use mode on, right? So this is port channel number 1, right? So we'll go ahead and do that. What is in those interfaces? FA011 and FA012. We got to do it on both sides. Remember what he said. The distribution layer switches are active. So remember, this is meaning they both will actively try to create a port channel, right? We're going to have an active side and one that's just a passive side, right? But these are both distribution layer switches, so they want them to be both active, right? Now, it's best practice to keep shut down the physical interfaces, shut them down before you start, configuring port channels and stuff like that. I used to do this at work all the time. You just putting interfaces in the port channels, and then the shit will shut down, and you got to rebuild it and stuff like that. It's best to shut down the physical interfaces. You used to do it all the time at work, and it would just like, we had like 2 hours to do a change, and it'll be like, fuck, what the hell's going on here, man? I'm trying to shut it down and bring it back up and build it and rebuild it, and it was just like, man, just always shut down the physical interfaces before you bundle them in the port channel. So in this case, we got to do FA011 and FA012, right? So go to the distribution. Excuse me, DLS1. Don't worry, I'm COVID free, y'all. Let me stop talking about COVID. FA011, NFA range, FA1011 through 12. And I'm going to go ahead and copy that. Copy. Y'all make sure y'all join that Discord server if y'all want that study sheet, man. I worked hard on that study sheet, man. Shut down. And then we're going to go on this side, DLS2, shut those guys down. Notice we already got some messages here. Configure terminal. Interface range that. Shut those guys down. So now, both these guys and these guys are now down, right? Now we can start working on the port channels and stuff like that. Group them. And he said put them in what? He said to put them in port channel number 1. And he said use mode on, right? What does that do? That puts the protocol on neither. It just puts it into I like to call it a regular port channel. It's not a Cisco proprietary one. It is not an open standard one. Actually, it is an open standard one. There's just not no protocol. So you just do on, it just bundles it into a port channel. Now I'll show you, right? So we said channel group 1 mode on, right? Yeah. Notice it's creating a port channel, interface port channel 1. We didn't have a port channel there yet, right? So we can verify that with let's do the other side. Let's do the other side before I finish doing all that. I did shut this down, right? Yes, I did. Okay, good. So now do the same thing over here. Yeah, we're on that range. We said channel group 1 mode on. Creating a port channel, interface port channel 1. So it's like a logical port channel, right? So we took these physical links right here and bundled it and put it into one, and it's gonna be port channel number 1. Well, I can show you. Do show interface status. Where we at? It'll be another status. I think so. Yeah, there it is right there. PO1, right? So we have these physical ones. We have this one that just automatically appeared, right? Got any questions, man? If I can't get to your questions, man, there's some people in the chat room. A lot of smart people in the chat room that'll help you out. We got Malachi, Fitness CEO in the building. Appreciate you for tuning in. We got Kelvin Tran in the building. We got Professor Black Ops in the building. Appreciate y'all for tuning in, man. No days off. Salute. So let's see. Let's go ahead and let's go to port channel. Actually, yeah, let's bring it up now. So now we're doing no shut. Right? Do I want to do that? Yeah. No shut. Do the other side. Create a port channel. No shut. And then should bring it up. So the physical interfaces are up. There goes port channel 1. Now it should be up. Verify our work with. I like show. There's a whole bunch of EtherChannel commands you could do to verify it. I like to do show EtherChannel summary, and we have port channel. I'm sorry. Physical interface 11 and 12 are up, right? So we got these. Pay attention to these legends here, right? It says port channel 1, right? The capital S lets us know it is a layer 2 port channel. We do layer 3, right? Add it to add a IP address and stuff like that, and then make it a layer 3 port channel. The U lets us know it is what? In use. And then the P lets us know it is bundled into a port channel. So that's good to go there, right? So we did port channel 1. What we said? The 2 ports between DLS1 and ALS1 belong to channel group 2 and use LACP. So what he said, DLS1 and ALS1, right? So now we're doing the same thing, but we're doing a port channel 2 now, right? So I guess I can leave those right there, right? I'll leave that one right there, right? So he said DLS1 and ALS1. So this link right here, let me do it black right there, right? Well, let's pick a different color. This link right here is going to be in port channel 2. That's port channel 2. And they said use LACP. That lets us know, I think that stands for Link Aggregation Control Protocol, if I'm not mistaken. That lets us know it is a Cisco proprietary port channel. So this is the protocol that was invented by Cisco. And am I correct in saying that? Yeah. I'm sorry. My bad. LACP is the one that is the open standard one. So PAgP, that is the Cisco proprietary one. So don't let me you correct me if I'm wrong, but yeah, that's what it is. So LACP is the open standard one, and PAgP is the open standard one. I used to get those mixed up. I'm probably mixing it up right now. Y'all correct me if I'm wrong though. So they want to put this in port channel 2 using LACP. So let's go to those links, right? FA0, 7, and 8. I'm gonna shut them down. Where we at? DLS1. Interface range. FAST 107 through 8. What am I missing here? Oh, I'm missing the range keyword there, man. What's wrong with me, man? Run me my lights. Run me my lights, man. Saying rocking the building. Appreciate you for tuning in. He said, "Oh yeah, so shut these guys down." And I'm gonna do the same thing on the other side, 0 through 7, and shut these guys down right here, right? And then bundle them in the port channel, right? Because you don't want to misconfigure them or anything like that. Like I said, I used to run into that shit all the time at work, man. DLS2. I'm sorry, not DLS2. ALS1. Where's ALS1? Right here. I hope y'all are doing this along with me, man. Don't just watch. Because you'll learn more as you're doing it. As opposed to just watching. Like I said, I used to just play CBT nuggets in the background, hoping I'm learning this shit through osmosis. Nah, man. Like, you can watch the stuff, but if you're not really taking notes or actually hands-on with it, man, it's kind of harder to learn. It won't really stick unless you're doing it hands-on. So interface range, FAST 10. What you said? 10. 7 through 8. 7 through 8. Shut those bad boys down. We're gonna put them in channel group 2, and we said mode is what mode? LACP. So, and we'll verify that too. I forgot who said it in here, man. It was a while back. We were doing port channels. Somebody said if you're not using if you're not using PAgP, you're lacking, which meant you're not using the Cisco proprietary version. So that's how I kind of remembered it, right? So now we just do channel group, and we said the DLS side needs to be, or the distribution layer side needs to be the active side, right? The one that is actively trying to create the port channel. The other side, remember we drew the yellow sad face and made him passive, right? I don't know why I'm making a passive guy sad, but whatever. DLS1, right here. We're gonna say channel group 2 mode. There was a way to actually force the protocol. I forgot what protocol, what command that was. It was like channel group or port channel protocol. Correct me if I'm wrong, or let me know what it is. But I think there was a way to force a specific protocol. I forgot what it was. But we said we're gonna make this the active side. So I think it's just active. And then notice we're creating port channel 2, but I don't think it's gonna be up because we shut the physical interfaces down. So those guys are down. I need to try that Microsoft whiteboard like Joel was saying, man. Alright, so now we go to the other side, this side right here, and put those in a port channel. We're gonna make it passive though, right? So active and passive, which those make sense to me, but Cisco decided to use other verbiage. That's how I remember, okay, it's not the Cisco version, right? So what was it? ALS1, which is this right here. We say channel group 2 mode passive, right? That creates the port channel. Now let's bring it up. No shut. Do the same side. I mean the other side, right? So we just brought this side right here up. That side right here up, right? But it should not come up yet, right? Because this one is still down right here. Let me see. Where's he at? Yeah, see, now the physical interfaces are still down, right? Until we bring the other side up. So now we do a no shut on this side. Channel protocol. That's what it is, Kelvin. Like I said, oh yeah, the SIGs of the day, man. I'm not kidding. Let me keep up to this chat right here. Let me see. He said STIG of the day. Switches use the default VLAN to communicate with directly connected switches. Y'all know what the default VLAN is, right? Usually out the box is VLAN 1, right? Using spanning tree, VLAN trunking protocol, and port aggregation protocol. So switches use the default VLAN to communicate with directly connected switches using STP, VTP, and PAgP. So that is the stick of the day, y'all. Right? Y'all know what that is, right? Security technical implementation guides. So like I said, those are like kind of like standards that are used with governmental agencies and military and stuff like that. Professor Blackout said all untagged traffic, the default VLAN may unwisely span the entire network if not appropriately pruned, which remember we discussed pruning, so that we don't want to put all of our VLANs going across the entire network, right? We want to prune our trunks, right? Unwisely span the entire network if not appropriately pruned. The risk of compromise can increase significantly. Yes, so that is the stick of the day, you guys. And like Kelvin just said, channel protocol is the command that I was thinking of. So we can force LACP without doing the active and passive and all that stuff, and then just do channel protocol. Do I have it on this version? Let me see. Channel, what you said it was? Channel protocol. Protocol? There you go. That's what the command I was looking for. See, now you do LACP or PAgP. But I'm just doing, but remember the book said they wanted us to have one side actively creating a port channel and the other side passively creating a port channel. That's why I went with the active and passive. But yeah, this was the other command that I was thinking of, channel protocol. So we can force a specific type of protocol. So now that we've done the active and passive, we can verify our work with my favorite port channel command, show EtherChannel summary, and that lets us know that port channel is LACP. So like I mentioned, this is the open standard version, open standard protocol, whereas PAgP is a Cisco proprietary. And like I said, I don't remember who it was. It might have been Pete, one of you guys. I can't remember. One of y'all said that in there. He said, well, no, channel protocol is basically a mistake prevention mechanism. You'll still need to do the active passive in your command. Oh, okay. Okay. That's good to know. But there's actually something else that we could do to actually prevent that. And I think that's in this lab too. So we'll go over that in a second. But like Kelvin said, y'all, channel protocol is basically a mistake prevention mechanism. So we may or may not want to do that. But either way, it performs the port channel and puts it in LACP. So what was the next one? We did port channel 1 right here, port channel 2, and then they want us to do port channel 3, 4, and 5. So let me go ahead and hurry up, right? So port channel 3 is between DLS1 and ALS2. So this is port channel 3 right here. That's port channel 3. And then they want us to use PAgP. So we could force that, or we could just use the active and passive side. So I'm gonna make this guy again passive, and then this guy, or this guy's active because he got the sad face. He's gonna be the passive side, right? That's port channel 3. Port channel 4 is gonna be between DLS2 and ALS1. So this right here is gonna be port channel 4, and obviously this side right here is port channel 5, right? So let me just do some labeling. This is PAgP, PAgP. Sorry for my bad handwriting. Port channel 4 is going to be LACP. If you're using PAgP, you are lacking. Or if you're not using, I can't remember one of y'all said that, man. That's how I was like, that's a good way to remember it, man. And port channel 5 is also going to be PAgP, which is the Cisco proprietary one. I need to figure out a way to remember it, but one of y'all said it, man. That's why I fuck with y'all, man. Y'all help me remember some of this stuff. All right, so let's go to this port channel right here. Port channel 3 between 9 and 10. So I'm gonna go to DLS1. Where's he at? Right here. I'm gonna put interface FAST 109 through 10. What am I thinking, man? I keep forgetting the range command. Sorry, y'all. Shut those bad boys down. Do the same thing on the other side. Like I said, y'all don't have to do this, but like I said, I used to run into shit all. And once I figured out, let me just shut these down and then try to do it. And for some reason, it always worked for me. I don't know why. Maybe I was like nervous during my changes and stuff, man. I don't know, man. Well, I'll be fumbling. So ALS2, where's ALS2 at? Shut those physical interfaces down. Shut. And then we're gonna put those in port channel 3 and do PAgP, right? So I'm gonna say channel group 3 mode. What am I on? ALS side, so that's the passive side. So if we're doing PAgP, that means it's gonna be auto. Now, for some reason, Cisco's verbiage is desirable and auto. So one side is desiring to become a port channel, the other side is auto, whatever the hell that means. I guess automatically become a port channel with the other side. I like the active and passive. That makes more sense to me. I don't know why. Y'all know they like to trip us up just to fuck us up on the exams, man. That's probably why they came up with funky terminology like that. Whatever. Channel group mode auto, and then the other side, notice we're creating port channel. The other side was DLS1, which is over here, and we're putting that in channel group 3 mode desirable. That's creating a port channel. Now we can shut those bad boys, right? But let's see what happened before we do that, right? Do show EtherChannel summary, and we'll see probably some different, right there, see? We created port channel 3, but notice now we have an S and a D as opposed to S and a U. What is that? S lets us know it is a, not that S, but a capital S, so pay attention there. That is a layer 2 port channel, but we have a capital, capital D there, pause. That lets us know it is down. And then, but we do have the PAgP protocol. So again, PAgP, the terminology is desirable and auto, and then LACP is active and passive. That makes more sense to me, like I said. And notice we have some D's here, right? And lets us know that those are down. So now we shut those bad boys. No shit, right? How many times you've done that, right? To go to the other side, the ALS2, and then no shut. All right, let me take a look before we can do that, right? Notice we did that, but the physical interfaces are still down, even though we did a no shut. All right, let's take a look at it again. Show EtherChannel summary. What do we got? Probably gonna be the same thing. Yeah, SD, they're still down, right? Till we bring it up, right? On the other side. So we go to the other side. So again, this side is up, right? This side right here is up, whereas this side is down right here, right? Or I'm gonna put an X there. That side is down. So until we bring this side up, that's when we're gonna create this little port channel right here, right? So let's go ahead and do that. ALS2, right? Yeah, that's ALS2. No shut that bad boy. And then let's see. They should bring it up. We should have a port channel 3 coming up. Come on, cross fingers, man. Let's get on our knees and pray to the network gods, because for some reason, there it is right there. Port channel 3. All right, there we go. So now we do a show EtherChannel summary. And he has only one port channel, obviously, right? Because it's there, right there. We didn't create this one yet, nor did we create this one yet, right? So he only has one port channel. SU lets us know is layer 2, and it is in use. These P's, obviously, again, means bundled in port channel. So now let's go ahead and do 4 and 5. And let me go a little bit quicker here. DLS2. Where we at? 9 and 10. Y'all got any questions or any suggestions or anything? 9 through 10. Where's the other side? DLS. I'm sorry. Not DLS2. That was 9 and 10 on DLS2, right? Yes, 9 and 10 on DLS2. Now I gotta do the 9 and 10 on ALS1. Shut those bad boys down. And then what type of emitter? He said he needs to be LACP, right? LACP, which means it is going to be active and passive, which makes sense to me. So channel group 4 mode. I'm sorry, yeah, mode. So the ALS1 is going to be the passive side, right? Because he's the access layer, right? That's why he got a little sad face here. So he's the active, he's the passive side, and then he's creating port channel 4. So now we go to DLS2. Where's DLS2? There he is, right there. And then channel group, he said channel group 4, right? Yeah, channel group 4 mode is going to be active. Now we can no shut this bad boy. What he said, it's just that it'll stop you from accidentally configuring once. Oh, I already read that part. So Luke, yep, appreciate y'all for tuning in. So we know shut that. That side is down. This side, so where we at? DLS2. This side is still down, even though I know shut it. I need to bring this up right here. So I need to bring this side right here up for them to become port channel 4, right? So let's go ahead and do that. I did DLS2, so I need to do ALS. That ALS1. Yeah. So no shut that bad boy. We're gonna get into multiple spanning tree after this, I believe. That turned that up. We got one more port channel, and then we'll be on task number 3. That's port channel 4. So that is up. Verify our work with show EtherChannel summary. Now there's some other port channels commands that you show commands that you can do. Did I do that correctly? Yes, he only has, let's see. Yeah, LACP and LACP. Okay, so let me ask you this. Yeah, this is the LACP one, and that's the other LACP one. That's why. Right? Is that correct? Port channel 2. Let me make sure I did that correctly. Port channel 2 is where? Yes, that's right. So this is LACP, and that's LACP. That's why. I was looking at ALS one side. So now I gotta do this final port channel right here. Port channel 5. Let me go to DLS2. DLS2 and ALS2. Let's do ALS2 first. Interface range, FAST 7 through 8, right? Those right there, 7 through 8. And get rid of all this shit, right? So that way y'all can. Sorry for my little squiggly marks here, y'all. Copy this. Bring that over. I know I gotta try the whiteboard, man. Somebody mentioned made a suggestion to use Microsoft Whiteboard. I just hate having to learn a whole new application when I'm like, I'm so used to Paint, man. I've been using Paint since like the 2nd grade, man. So like I know the commands and the shortcuts and everything. So that's why I don't want to use it just yet. But you know, being that I'm got a whole new YouTube channel, I should use some more professional applications, I guess. 7 through 8. 107 through 8. Shut those bad boys down and say channel group. Let me see. No, I'm not gonna put them in the channel. I'm not gonna put it in the channel. Let me shut these guys down too. DLS2. Interface range FAST 107 through 8. Shut. And then channel group 5. And what mode did he say that he needed to be in? I can't remember. Y'all know I got a memory of a goldfish. You use PAgP, so that means not active and passive, but yeah, active and passive, right? No, sorry. PAgP is the Cisco proprietary one, so desirable and auto, my bad. So mode, I'm on the DLS side, so this needs to be desirable. And then we created port channel 5, so we go to the other one, ALS2, right? So we created port channel 5 over here, right? But he's still down because we shut these guys right here down. Shut that guy down, shut that guy down, and we also shut that guy down. So we need to put create port channel 5 on this side by we made this side active. I'm sorry, desirable. We made this guy desirable. We're gonna make this side auto, right? That should form a trunk. So channel group 5 mode. Am I on the right? Yeah, I think so. ALS2, right? Yeah, I'm on ALS2. Let me see. I gotta get caught up. I'm sorry, y'all. I'm ignoring y'all. Oh yeah, okay. So y'all not saying nothing. Good. So mode passive on this side. It's creating port channel 5. There's no shut that bad boy. No shut the other side. And finally, move on to task number 3. We only got 6 tasks, so we should be halfway done. No shut this guy. Show EtherChannel summary, and I'm gonna run some other show commands that y'all can show y'all, but it will give you a lot of detailed information that you may or may not need. So now we got a W there. What the hell is a W? Waiting to be aggregated. Look how quick I caught that, right? So we got a W there, and then and I ran that show command really quickly, so that's why it is waiting to become a trunk. I mean a port channel. And notice we got the physical interfaces come up, so we should have a port channel 5 message as well. We got the PAgP protocol lets us know. Come on, port channel 5. What's going on here? Oh, I think it was created already. Show EtherChannel summary. And now it's down. Interesting. So, did we do the other side? That's the other question. ALS2 is what I needed to do. I needed the ALS2 no shut. That's probably what it was. I did it so quick. So that was a good way to see what happened when we no shut one side, right? Where is he at? We have this right here. Now it is I, which lets us know it is independent or standalone, right? They couldn't use S, so that's why they put I's there, right? And the port channel is down. So port channel 5 is right now is down. We can verify that with what show. Well, you see that right there, but we do show interface status. That lets us know I'm too fast for it, right? Trunk, and it's not connected to port channel 5. We could also do show EtherChannel, what is it, port channel, something like that? I think show EtherChannel port channel, and it gives us like a lot of information, man. Like it's almost too much information, man. Lets us know how long it's been bundled to a port channel. That's port channel 1, the first one we did at the beginning of this video. I guess that's how long I've been streaming for. It's 8:51. Shit. Let me move on, man. But yeah, that's another way. And you could add the detail keyword to see even more if that's not enough, right? Is it there? No. Show channel, EtherChannel detail, like that. And it's a pretty similar command. So shows you the master in the bundle, what interfaces they are, how many are in that port channel, how long they've been bundled in a port channel, etc. Right? A lot of information. I just like to use show EtherChannel summary. It's just real clear and concise information. Plus, they give us this little legend. If it wasn't for this big ass legend right here, this is all we really need is to really see what it is. But you know, you ain't gonna know what all these letters mean until you look at this legend here. So it is what it is. Let's go bring the other side up, which is ALS 2, 7, and 8. ALS 2 is over here. No shut. It's been queuing up right there, right? I guess I won't shut up. That's probably why it's taking so long for these damn port channels to come up, right? Did I no shut this guy already? I did. So let's see. Let me see. Did we bring it? It looks like we got a little whatchamacallit, troubleshooting we might have to do. DLS2. Let's take a look at him. It is down? Yes, it is down. Alright, so we need to troubleshoot port channel 5. What is going on here? Port channel 5 should have interfaces 7 and 8. Let's see. Let's look at show FAST, show run, interface FAST 107. Desirable. The other side should be auto, right? So 7 and 8 should also be desirable, and the 7 and 8 on this guy should be auto, right? So 7 and 8, whereas 7 and 8 on ALS 2, right? Let's see. ALS 2 show run interface FAST 107. I'm missing a bunch of stuff. Oh, he's not trunking either. I need to trunk it. That's why. Hey, that's why. Let me shut those guys down. See, I don't like this. I don't like this. I didn't make these guys trunk. Let's fix that. Let's fix that. They should be trunking though. 7 and 8. Show interfaces trunk. I don't think that's the reason though. See, because remember we negotiated the other side, so 7 and 8 should be trunking, as indicated with this show command. Right, so it is trunking, but port channel 5 is not up. Do we have? Oh, did I put? Yeah, I put channel group 5, so that's correct. Other side should say 5 as well, right? Channel group 5, mode desirable. Interesting. What is going on here, y'all? Let's see. I don't wanna hard code it as a trunk. Maybe I should, but it looks like we might have to rebuild this port channel because port channel 5 is not coming up. So let's do this. Show EtherChannel summary on ALS2, right? What we got? Independent, and they are down. So let's do this. I'm gonna rebuild those port channels. I said auto. Did I do auto on that? No, passive. That's the problem. I used the wrong keyword. That needed to say auto. That is the problem. Y'all see that? Always verify your work. Remember, one side got to be desirable. If you have one side that's desirable, the other one got to be auto for them to be or it could be desirable. Those are the combinations you can use. You can't use desirable and passive. That's a misconfiguration. So, just like what Kevin was saying. So, if I would have hard coded it with the channel protocol command, I probably wouldn't have ran into this problem right here. That's why it's down. So let's fix that. Like I said, I like to shut them down before I rebuild them. So, interface range, FAST 107 through 8. I'm gonna shut those bad boys down, and then let's get rid of this right here. We put passive. They don't need to be passive. They need to be auto, right? Because we said this was going to be port channel 5, which was PAgP. That's correct. So that is the problem, right? So we shut it down. We'll say no this. That gets rid of it. And now we say channel group. You know what? Let's do this. I want to shut the other side down too before we do all of that. Oh, the port channel? No, we didn't. So what is it? DLS2. I'm gonna shut this. I'm gonna shut this side right here down before I do all of that. That's just how I work, man. Because like I said, I used to run into stuff all the time until I shut it down, do my configurations, then bring up the physical interfaces, then it'll come up. So configure terminal. We say interface range FAST 107 through 8. I'm gonna shut these guys down, and then on ALS1, we say channel group 5 mode. It was supposed to be not passive but auto, right? Now we can bring these bad boys up. Before we do that, let's show EtherChannel summary. Do a show EtherChannel summary. Let me my lights, man. Shut EtherChannel summary. Yeah, I want to shut this thing down, right? So they're down. Now it looks like we have a good backport channel 5 PAgP. Yeah, that's exactly what we wanted. So now let's bring these bad boys up. No shut. Do the other side. All right, so now we're gonna bring this side right here up. Hopefully our port channel comes up. Right, no shut on DLS2. Get on our knees, pray to the network gods. The physical interfaces are up. And our prayers have been answered. Port channel 5 is up. Good to go. So let's verify that with show EtherChannel summary. That's my favorite port channel command. And now we got P's there. Pause. Exactly what we wanted. Port bundled into port channel. So that was the problem. We used the wrong keywords there. And like Kevin was mentioning, we could either do this channel protocol command hard coded as either LACP or PAgP. Now I want to run into this shit right here. So finally, task 3. Following the EtherChannel configuration, protect the switch network from any feature misconfigurations by ensuring misconfigured EtherChannels are automatically disabled. Maybe this is what we needed to do at the beginning before NetworkBruh fucked it all up. So again, following the EtherChannel configuration, protect the switch network from any misconfigurations by ensuring misconfigured EtherChannels are automatically disabled. What is that feature? That feature is called, and I saw this earlier, and I was like, this threw me off though. So we do. Here's the other thing too. If we, I'm going all over the damn place. If we there's so many ways that you can fuck up a port channel, like I just did right there, right? And y'all see how I had to fix it. I had to make sure I remember the keywords and stuff like that to make sure that they build a port channel, right? So we could do this feature to prevent that from happening, or we could do the channel protocol to prevent that from happening. What else could we also do? There's another way to do this. I like to shut it down, but that's obviously not going to prevent it from happening. If you don't know what the hell you're doing, shutting it down, they go solve the problems, and that's what I did, right? But I just, like I said, before I start building my port channels, I like to make sure the physical interfaces are shut down. So that command that they're talking about is disable, because a lot of times if you misconfigure it up, your port channels and stuff like that, while they're up and stuff, I've seen it where while the physical interfaces are up, and you're trying to build a port channel, it'll put it in disabled mode, right? What's that? It stops traffic from coming across if you have, depending on what disable mode you have it in, and then it basically shuts the port down. Not really shut it down, but it renders it disabled. Hence the name disable, right? So we do a show. What is that feature? We can see what they are. Show disable. What is those features? Recovery. We can see which ones. There's so many things that we could fuck up, right? And disable, we would say, hey, if somebody like NetworkBruh comes on our network and screws it all up and does any of these, let's make sure that the port goes and disabled. There's all these features right here, right? We have, let's say somebody puts in a switch or a device that starts sending out BPDUs on a port that we don't want. So we have disable BPDU guard. Right now it's disabled globally. The feature that they want us to do is don't let this confuse you or throw you off. That's when I saw this, I was like, I think this is it right here, because it is channel misconfiguration. But what is this STP is? That's the reason why. Because if you misconfigure your port channels and the ports are still up and stuff like that, you can cause loop to happen. So that's why they put in here STP, spanning tree protocol, right? What's that? That stops loops from happening at layer 2, right? So What do you say? Y'all any questions or anything so far? If I can't get to any questions, a lot of smart people in the chat room and stuff like that. Man, run me my likes, man. Run me my likes. And subscribe if you're not subscribed to this channel. So, we said we need to turn this feature on, basically. Right now, it is obviously what? Disabled. Screaming in red at us here, right? Let's do that on all these guys, right? So that feature that they asked us to put on is, says here, where is it? I can bring it up. Yeah. So protect the switch network from any feature misconfigurations by ensuring the misconfigured ether channels are automatically disabled. That's what it is. It's going to disable it, right? Then he also said, additionally, configure the switches to automatically bring up the ether channels that were disabled due to misconfiguration after 10 minutes. So after somebody like NetworkBruh goes on your network and screws it up, it's going to obviously disable the port, renders it useless, and then as soon as he leaves the data center, we're like, okay, I think we're good. Usually he leaves in about 5 or 10 minutes. They said 10 minutes. Go ahead and bring it back up, right? And then we'll have a real network engineer come in here and figure this stuff out for us. So let's do, right now, by default, the timer interval is 300 seconds. All of this stuff is disabled, right? I thought it was all enabled by default. I guess they're all disabled by default. Yeah, they're all disabled. So they want us to specifically put that one to come up after a fuck up, after 10 minutes, and also go ahead and enable it. Right now, it is 300 seconds, which is, I believe, 5 minutes, right? Yeah, I believe that's 5 minutes. So go to global config mode, and this is a global command, so it is done on the whole switch, right? We got to do this on all of the switches. So spanning tree, is it spanning tree? Can't remember how you do this. No, disable, disable, recovery, feature, can't remember, interval. No, the interval is the 10 minutes part, so we can do this part. But we can do it only in seconds. So 10 minutes, yeah, because 5 minutes is 300, so it'll be 600. So now we do a show, disable, recovery, and we'll see if I can spell. Disable recovery is now set to 600 seconds, but we didn't enable this feature just yet. We enable it with disable recovery cause channel misconfiguration. Now we do a show that, and we'll see it's enabled. So NetworkBruh can't mess this up now, like he did 10 minutes ago, right? So now we have to do the same thing on all the other switches, right? Spanning tree, not spanning tree. Well, I'm so used to doing spanning tree. Disable recovery. We say interval is 600 seconds. Disable recovery cause channel misconfiguration. So let me just copy and paste it because I can't remember all that. It's too much. Let me not copy and paste. I should do that just to kind of remember, right? Repetition is key to mastery. Spanning, I keep doing spanning tree. Disable recovery interval 300 seconds. Disable recovery cause channel misconfiguration. Let's do the same thing. Let's say it out loud, right? Disable recovery interval 600 seconds. I did 300 on the other one, or did I do 600? I did 300. I did that wrong. Come on, man. Y'all, let me know if I'm making mistakes, man. I'm depending on y'all, man. 600. We did 600 here. Disable recovery cause channel misconfiguration. So as soon as NetworkBruh comes into our data center, we won't fuck it up, right? So where we at? Let me refresh real quick. We are still on task 3, right? Yes. So that was task 3. Task 4. We only got 6 tasks here, y'all. Task 4. Configure VLANs 100, 200, 300, 400. God damn it. 100 through 800, but in those so 100, 200, 300, 400, 500, 600, 700, 800 on all switches. Use the default VLAN names or specify your own names. Well, guess what? I'm not going to put my own names. I'm just going to leave the default VLANs, and if so desired. So this should be easy, right? We know how to configure VLANs, right? What's that? Virtual local area networks is a way to segment our network at layer 2, right? So we got to do 100 through 800, not 100 through 800, but those VLANs on each switch, right? How many VLANs we got so far? By default, they should be just 1, right? VLAN 1? Yes. VLAN 1. And we have these that are in there by default as well, but you can't modify or delete them. They just stay there, right? These are like old, they're called legacy VLANs, so you can't even touch those. Go to global config mode, VLAN. We said, now this I didn't know you could do. I knew you could do this right here, 100 through 200. But this I didn't know you could do. I had to like experiment to really, I'm like, as much as I've been playing with VLANs, as long as I've been doing this, I didn't know how to do this shit. Come on, man. 100, 200, comma, 300, comma. I think the reason why I thought it should work like this is because I used to put a space. And that's why it never worked for me for all these damn years, man. 500, 600, 700. I forgot the 600. Fat Finger Squad. 700, comma, 700, comma, 800. Right? This is too repetitious, so too monotonous, too tedious. So I'm gonna go ahead and copy paste that. Right? 100, 200, 300, 400, 500, 600, 700, 800. Right? Do the same thing on other guys. Exit. That should create it. Let's do a show VLAN brief just to verify that they were created. They're created. We'll leave the default names. Do the same thing on this side. Exit. They don't get created until you exit out of that mode, right? Because if I do like this and then do a show VLAN, do show VLAN brief, they're not created yet. They don't get created until you exit out of that VLAN configuration mode, right? You exit. See how I waited there for a second? Now do a show VLAN brief. Then they're created, right? So remember that. Go to global config mode finally on this switch. Create those VLANs. Get out. Do a show VLAN brief. I believe that was task 4. Yes. I'm not creating names. I'm skipping all that. Task 5. Now this is what I need work with, right? Multiple spanning tree. It's one of those spanning tree flavors that is a way to kind of like group our spanning tree instances. So, you know, we have like spanning tree, our PVST, the spanning tree, the classic spanning tree mode, right? There's all these spanning trees, and we could choose one specific switch to be the root bridge, like we did on the last lab, on the last stream, right? But we could do one specific switch to be a root for a group of VLANs, right? As opposed to, and we put those groups in what's called an MST instance, or multiple spanning tree instance, right? So, I'll probably go back to doing my tutorials. It'll look better, and I explain better when I have all my, you know, my funky graphs rather than doing all this crazy ass drawing when I draw this shit, right? Because if I'm trying to draw a spanning tree topology on this shit right here, y'all gonna be like, man, what the hell is this guy doing, man? Like, I don't understand this, man. So I'll go back to doing my tutorial soon, but y'all know I like doing these streams because it's just like, it's just more fun to me, and I get like a little, you know, I get interactive with you guys and stuff like that. So let's go ahead and task number 5. Selecting your own name and revision number. Configure multiple spanning tree as follows. VLANs 100 and 200 will be mapped to MST instance number 1. Switch DLS1 should be the root. So, again, I'll write it out so y'all can see, right? And if you guys want to follow along, you can get a copy of the book. It's called CCNP 101 Labs. You can get a copy from 101labs.net. There's also a link in the description box below. It'll take you to Amazon. You can get the book from there, and you can follow along with us and stuff like that. I like using hardware. You can use GNS3. You can use, you know, EVNG or whatever floats your boat. Y'all know I'm old school, and plus I had this fucking equipment sitting here for a long ass time. I'm like, I get to finally use it, right? So they said put VLAN 100 and 200. I'm laughing about this bonnet, man. Oh, yes, I'm screaming with a damn bonnet on. Like I said, I'm growing out my hair, and in the light of people talking about women putting their bonnets in public, I stand with y'all, man. So that's why I got my bonnet on, all right? So VLAN 100 200, we're putting that in spanning tree instance number 1, and we're going to make this guy the root, right? So I'm not going to draw some roots. Y'all know I like to draw. We're going to make him the root bridge for those VLANs in that instance. Because remember we did that? We just did that for one specific VLAN and made him the root. We're going to make him the root and give him a crown, right? You drop this king. Give him a little crown right here. He's going to be the root bridge for VLANs 100 and 200, right? But this time we grouped them up into one instance called instance number 1. We can actually name the instances too. That's what's cool about MST, right? I forgot about MST. I ain't forget about it. I just haven't touched it in a long ass time. As long as I've been streaming and doing all these tutorials and stuff, right? So, and the way you get in that mode is spanning tree, spanning tree mode. First we need to put, let's do this before I even do all that, right? Let's go to the DLS1, right? I was on the wrong switch for 1. So spanning tree. Let's just show spanning tree, right? We'll see what mode we're in. We are in IEEE. I believe that's classic spanning tree, right? No, that's rapid PDST. How we do that? I think we do show, because I wonder if there's a way to show the mode. Show spanning tree summary. Yes, so that lets us know it's in PDST mode. They said multiple spanning tree, so we need to change the mode and then start playing with the modes, right? So global config mode, spanning tree, mode, MST, right? I press enter, pray to the network gods. We should change up our spanning tree topology by doing this, right? It's gonna get all funky. We're gonna be picking root bridges and doing all this funky stuff, right? Until, let's see, did he turn down any other ports or anything like that? Nope, nothing. But we do have VLAN 1 that went down, probably because it's blocking on all ports. Let's see, do show span VLAN 1. Let's see. Yeah, it is blocking that port. It became alternate. We do have a root port. It's learning. Let's see what happened on that port channel. It's still learning. Forwarding there. And now it's up. So it went down. So now it chose a different port to block and chose a different root bridge for that spanning tree, for that VLAN, right? But he's still running in PDST. We need to change all of them to MST. So that way they all can be in one happy MST family. Y'all got any questions or anything so far? Or am I losing anybody? Or let me know, man. Like I said, if I can't get to it, if I can't answer your question or whatever, or if I'm making things a little bit more confusing, let me know. There's a lot of smart people in the chat room that can help out and stuff like that. I'm playing with my bonnet and stuff like that. They didn't have black, all right? So spare, like, bear with me, man. They had a pink one. I was like, nah, hell no. Let me go ahead and brown, I guess. I could have ordered it on Amazon, but they were a little cheaper, so. Yes, I'm wearing a bonnet, damn it. Switch one. DLS one. So we say spanning tree mode MST. Let's go ahead and do the same thing on all of them. Spanning tree mode MST. Do the same thing on this guy. Right? Y'all know the other spanning tree modes are? Spanning tree. There's MST we're playing with today. What are the other modes of spanning tree? Pop quiz number 2 for the day. Spanning tree mode MST. Right? There's spanning tree. We're playing with multiple spanning tree. What are the other spanning tree flavors? So, we did MST. Let's go ahead and do our configuration. So we can choose, remember the instances that I said we could create, right? We're going to put instance, he said create instance number 1, put VLAN 100 and 200 in them. And then he said also create a revision number. And Juan is just joining. What is MST? MST is multiple spanning tree. It's a way to kind of like group our spanning trees. There's different other flavors of spanning tree. MST is just one of them. It is a way to also, what else do I want to say about it? There's something else that I wanted to just say. It just popped up in my head. So we group our VLANs in the instances. We can name those instances. And spanning tree is basically a way to, if you know about spanning tree is a way to stop loops from happening at the network. Right? How do loops happen at the network? I'll just kind of, I might be going just a little off topic, just do a little deeper understanding for Juan. He just tuned into the stream, right? When we, let's say we got I'm just going to do just a brief explanation on what flooding can do and what spanning tree can happen, how spanning tree can happen, right? We have a laptop here. Brief explanation, right? That's an ugly laptop. I know, damn it. Got a laptop here. He obviously is a computer A. He's computer B. Right? Now, when he wants to send a message to computer B, he sends a message to this guy right here, right? This little message right here. Not necessarily a message, but any kind of traffic, right? Remember, we send our traffic at layer 2 in frames. So sending a frame, right? Right. If ALS 1 does not know where this PC lies, he's gonna do what's called flood the frame. So he takes the frame, this frame that comes in, he's gonna flood it on all these ports, right? Because he don't know where the hell it's at, right? So it's gonna say this, like, I don't know where that switch is at right now. I don't know where that switch is at. He's like, oh, I know what PCB is. I know where he lies on this port right here. Okay, great. So now, once we do that, that's how this guy built his MAC address table. He now knows where live PCB, so if he wants to send the traffic. But when he do these, if we don't optimize our network in a specific way, or spanning tree without spanning tree, when it does these flooding of these frames and stuff like that, we can cause a loop to happen, right? What's a loop, right? When we said we flood these frames, it sends copies it to everybody, right? Right? So this frame goes over here, that frame goes over there, and it could potentially cause a loop. When these frames, they will just like loop all day long, just looping, right? Just spinning, just this traffic. And there's a way if another one makes a copy, and it'll just be like, and it could take down our network, right? Spanning tree stops that from happening. There's different flavors of spanning tree, like I mentioned. There's nobody said it. So there's rapid PST, there's classic spanning tree mode. MST just happens to be one of those modes. There's just different ways to configure them, and they have different ways they work. Again, multiple spanning tree, or MST, is one of those ways. So I hope I explained that for you, Juan. It's just a brief explanation. It gets deeper than that, but that's just a brief explanation on how spanning tree kind of works and how it stops loops from happening. So it blocks specific ports. It creates a specific port to be designated to forward all of its traffic and stuff like that to stop loops from happening, and it's done automatically, right? Because by default it's turned on, so that way we don't have to. We just plug and play, right? Where were we at? He said just woke up 6 a.m. here. Oh man, appreciate you for tuning in. 6 a.m. and you tuned in to the network, bro. Appreciate that, man. Thanks to you, I get to revise everything right away. Thanks, bro. Appreciate you, man. Thanks for tuning in, man. Hit me with that like button, man. I appreciate all you guys for tuning in and stuff, man. So, where were we at? We were still configuring spanning tree, multiple spanning tree. VLANs 100 will be mapped to MST instance 1. Right? So we go to DLS 1. We say spanning tree. To get in that mode, we do spanning tree MST configuration. We do that. That puts us in MST configuration mode. So now we can start playing with spanning tree MST and configure it, right? So he said, what he said, select your own name and revision number. So let's create a name. I'm gonna call it, I don't even know what to call it. Let's just say bruh. Name, the way you name it is name, and then bruh. So I'm gonna say bruh 1. Span. That's too much, right? Let's say bruh span. Bruh span. Bruh hyphen span. We'll do that. Name bruh 1, right? A bruh span. Bruh span. Alright, so name revision number, which is this revision. And we'll say, we'll just do revision 1, right? So there's different revisions that we can have of our spanning tree instances, right? VLANs 100 and 200 will be mapped to instance 1. So let's do instance 1 and map those VLANs to it, right? So I think it's, if I remember correctly, instance 1, VLAN 100, 200. Yes. And then instance 2, they said 300 and 400. So 2 VLANs 300, 400, and so on and so forth till we get to 800, right? Y'all with me so far? Right? We're grouping those VLANs like we did, right? Right here, right? We say VLAN 100 and 200 is going to be VLAN in instance 1, 300 and 400 will be in instance 2, right? But we're just going to be picking different routes for those guys, right? We're just grouping those VLANs into different instances, and we're picking different routes. So in this one, he said switch DLS1 should be the route for DLS instance 1, right? And then we're going to pick this guy for another instance, route for another one. So they're all going to get crowns, right? Instance 3 is VLAN 500, 600, and then instance 4 is VLAN 600. 700, 800. What else they said? This switch should be the route for instance 1. So how do we do that? I believe it's spanning tree. No, I can't even remember how to do that. I got to think about this one. I could question mark through it. Y'all know I ain't got no shame in my game with the question mark, man. Let's see here. We did the instance mapping. We did the revision. We did the name. We could also do a show real quick. We do a show current because this stuff does not get applied until we exit out of this mode. So we do show current. We'll see what is the current's running. Instance 0. What the hell? It's 0? I didn't create instance 0. This is the default instance when we get into MST. All of them gets grouped into MST instance number 0 until we start creating our new ones, which we did 1 through 4. They didn't show up yet until we get out. So how can we verify that? Show pending. And now we can see the instances that are pending until we get out of this mode. Just like the VLANs, it doesn't get created. These instances don't get created till we exit out of this mode. But goddamn it, I need to remember how to make this guy root, and I can't remember how to do that. I think it is spanning tree. Do I gotta get out of this first? I think I gotta get out of this mode to do that, if I remember correctly. Instance, no. Let me see. Let me question mark real quick. I think I gotta get out though. Abort, name, no, private VLAN, revision, show. Yeah, I think you gotta get out. You gotta get out. And then do it. Exit, the spanning tree, MST. And we're changing our topology with this here too. So MST, root. No. What is it? I gotta remember. Oh, configuration. Yeah, it is definitely in configuration mode. Oh, but you gotta put the instance now. So now I do spanning tree MST. It's starting to click now, right? So spanning tree MST 1 and then root, and that's what I was looking for. Root. Now he's gonna be the root, but we can choose a primary root or backup. They ain't saying nothing about backup. They didn't say nothing about primary, but we're just going to go with that. Root, you have to pick one, either primary or secondary. So we just do primary, right? So now he's going to be the primary root bridge. He's going to be the root bridge for MST instance number 1. That's why we gave him the crown right here, right? And then we'll just go on. They said we got to create all those instances and the name and stuff like that on the other switches, and also choose different roots. So DLS2 is going to be the root for VLANs 300 and 400. So we'll go to DLS2, this guy right here, and he's going to be the root bridge for 300 and 400. I know I drew a 300, 400 over there, right? So he also gets a crown, right? You get a participation award here, right? Speaking of participation, y'all seen LeBron yelling at the game because they was talking shit about his son. They weren't really talking shit, but they just was like, man, oh, you wouldn't have done that. That wouldn't have happened if he wasn't LeBron's son, man. It's fucked up, man, because he's a parent, so I don't blame him for stepping up like that. So let's go to DLS2 and do the same thing what we did over there. Oh, before we do that, let's check our spanning tree instances. Show, span, MST. We do 0, right? That was the catch-all one. That was the beginning one, right? We do MST1, and we see that instance there. We are also the root bridge. I can't remember how to tell whether he's a root bridge or not, though. I don't think it's this. Because we do MST instance number 2 on this switch. He says this switch for MST. But y'all help me remember. I think that's what it is. The lower the priority lets us know that he is the root bridge. Right? I think that's what it is right there. That lets us know. But I thought there would be a more clearer explanation on that. So we do MST3 right here. He also has a default. So that kind of let us know that he is the root. Remember, the lower the bridge number or the lower bridge ID, the more likely it is to be the switch. So, I mean, switch. The more likely it is to be the root of a specific VLAN, or in this case, instance. So, where we at? DLS2. Do the same thing on DLS2, right? I'll be a little quicker this time. Spanning tree, MST. We did it. We put it in mode already. So, spanning tree, MST configuration. We said we gotta name it and give it a revision. So name, we said bruh hyphen span, revision, we'll say 1. And then the instances, so instance 1 is VLAN 100, 200, right? That's what it was, 200. Instance 2 is VLAN 300, 400. Instance 3 is VLAN 500, 600, and finally instance 4 was VLAN 700, 800. What else did we say we want to do with this? We want to make him the root bridge for 300 and 400, right? So we do a show current to verify our work. It's not in here. Why is that? What are we missing? We did put it in spanning tree MST mode, right? Didn't we? We put it in MST. We are missing a lot of stuff here. So we did show current. There's nothing in there. See that? Even though we said give them a name, a revision. Let's do show current again. Show, just show. There it is right there. Oh, that's what's pending. Duh, that's what the difference. Remember? It's pending and what's current. You gotta remember that. So this is what's pending. This is the work that is pending. Until we get out of this mode, then you'll see them current. So right now, when we do show current, what's currently running? What instances are currently running? None. Show pending. This is what's pending. We get out of this mode, and now we do a spanning tree MST configuration. We can do another show command, but I'm gonna do this right here so y'all can see the difference. Show current, what's currently running. Now we see the instances, the name, and the revision number, etc. Now we gotta make him the root bridge for VLANs 300, 400. So spanning tree MST 1, right? Isn't that what it was? Root? Yes, primary. Oh, jeez. Not 1. I meant 2. Instance 2. So let's get rid of that. No. That and say spanning tree MST 2. Because we could have caused a root inconsistency with this by doing that. Let's see. Did we get that? I didn't see anything. Probably got some kind of safeguard there. But we could have caused a root inconsistency with that. We'll see. Now let's do a show. Get out of this. Show span MST 1. I like the root bridge. That's 1. Yes, so 1. And then 2. Let's look at 2. We said we made them 2, right? For 2? Who did we make them 2? Spanning tree instance number 1 was... He needed to be the root for spanning tree instance number 2. And I am, because of that priority right there. But I thought it was much more clear to let me know I'm the root, rather than just by looking at that. Thanks, got it. So you are configuring STP MST. That's correct, Juan. So we're doing MST, multiple spanning tree, right? So again, if you want to, follow along, or if you tuned in too late to this stream, it's lab number 3 in the book. Let me see. Yeah, lab number 3 in the book, which is CCNP 101 Labs CCNP. 101 Labs CCNP. You can get a copy from 101labs.net, or there's a link in the description of this video. It's page number, what is that? Page 38, I believe. And that is how the topology looks. So you can follow along. Like, you can replay the stream if you want, if you like halfway through the stream. So let's go ahead and do. Yeah, we verified the show spanning tree and stuff on that one. We did the instances. Let's do the same thing on Switch ALS 2. Right? Is that what we got to do? Let me see. Let me verify. ALS 1 and ALS 2. So let's do ALS 1 and do those same spanning tree instances and make him the root for instance number 3. Right? So we are in MST mode. MST, good. We said spanning tree MST configuration. We give it a name. We're gonna name it bruh span, and I think we're gonna do the same thing with. We might do some Boson NetSim this week. I might do some Boson NetSim. I gotta make sure I activate those codes they gave me, man. Shout out to Boson, man. I'm gonna be giving some of that stuff away when I get to 5,000 subscribers. Like I said, they gave me some promotional copies for personal use, but I'm gonna also do a giveaway. Bruh span, right? That's what we named it. We said revision. I'm gonna give it revision 1. We also wanted to do those instances. Instance 1 is VLAN 100, 200. Instance 2 is VLAN 300, 400. Instance 3 is VLAN 500, 600. Instance 4 is VLAN 700, 800. Right? We do a show. We do a show current. What's currently running? Nothing. Right? Now I see. Now we do a show pending. We see our work there. It's pending. Remember, they don't get created. All these instances don't get created until we get out of this mode. Right? That's something I need to remember too. Like I said, I haven't played with MST since, I don't know, God knows how long, man. So, and the thing with spanning tree, man, it just kind of like, I ain't gonna say fuck your head up, but it's just like, man, you gotta figure out who the root bridge is and try to figure out the root ports to get there, which one's gonna be blocking. It just kind of, it just, like I said, it's kind of like a microwave. You don't know how it heats up your food. It just works. But for us to notice at a deeper understanding, we need to notice at a deeper understanding so that way we can optimize our network, our spanning tree topology and stuff like that. That's why we got to learn this at a deeper understanding. Plus, I'm trying to get my CCNP, so get out of this mode. Now we do a show. Actually, we don't even need to do all that. We just know it's pending. So, but if you want to verify it again, spanning tree, MST, configuration, show, current. Now it's currently running, right? We need to make him a root bridge for instance number 3. Spanning tree, MST, 1 root. I'm not not 1. We said instance number 3, which is 500, 600, right? This right here. He's gonna be root bridge for this. Spanning tree, root, primary, right? We do a show spanning tree MST. That should show us all of our instances right there, right? So MST 0, this is like the catch-all MST instance. Right, this is the one that's like made by default. Just groups everything into that spanning tree instance. Everything else, rather. See that? The ones we created, we mapped 100 and 200 in the MST1, right? You can see. That's why we got a space there. We got a space there because that's going to be another instance of MST, right? Y'all see that? That makes any sense? Because remember, we created 100, we created 200 there, we created 300, and put them in other instances. 0 just gets everybody else. That makes sense, right? He is the root bridge for, should be MST3, right? That's why we have a lower priority of that right there, right? We have higher priorities for these other ones because somebody else is going to be root bridge for those, right? Finally, ALS2 is going to be the root bridge for MST instance 4. So go to ALS2 and do the same thing, right? Y'all with me so far? We're almost done, man. We're on task number 5 out of 6. So we're about, I guess, 86% complete or whatever. More VTP, more MST. That's correct. Can you use VTP with MST to send this info to other switches? Yes, exactly. Kevin answered it correctly. In this case, he's just doing it manually. I don't know. I had to step away. Let me see. Yes, I'm doing it manually because we turned off VTP at the very beginning of this stream. So you might have to replay it or whatever. But I'll show you. Anyway, do show VTP status. VTP is off, so I'm doing everything manually, just as you stated, Juan. Correct. Because that's what they asked us to do. But I believe in the solution guide. I'll talk about it later. I'll talk about it towards the end. I set it to off mode. That's a spoiler. He put it in transparent mode. Remember, transparent mode means you can create, delete, modify VLANs, but they will stay locally. You can pass on everything else through you, depending on what mode they're in. They can get it. They can get the rest of the VLAN information, but everything that's created within you, deleted within you, modified within you, stays locally within you. If that makes any sense, right? He put it in transparent mode. I like to use off. So, actually, I think we used the transparent mode at work. But anyways, where were we at? ALS1. We need to do ALS2. Spanning tree. MST. Configuration. Span tree. We need to create a name. I'm gonna name it bruh span as well. -span. I don't know why I couldn't come up with a better name than that, right? Revision number 1. Make me run me with that like button, man. We also wanted the instances, right? Instance 1 is VLANs 100 and 200. Instance 2 is VLAN 300 and 400. Instance 3 is VLAN 500, 600, and instance 4 is VLANs 700 800, right? Do it again. Show. I'll just do a show current. Nothing. Show what's pending. Those are the ones that are pending. We get out. Then the spanning tree topology and instances are created. Not topology, but the instances are created now. Once we do that, that's why we have the interface VLAN is bouncing right here. And we also wanted to make this guy the root bridge for instance number 4, I believe, right? So spanning tree. What did he say? He said, well, it's too dangerous to explore too much too early. That's correct. Yep. Oh, well, MST has 0. Let's read it. Yeah, exactly. Seeing that those. I'm studying for CCNA, but been watching all these videos. Yeah, Juan, MST is more of a CCNP topic. I don't think they discuss or even cover. Should be cover MST. They might briefly mention MST in CCNA, but yeah, I believe I don't think they really. If you look in the book, they ain't gonna really go deep into MST spanning tree. So. What were we going to do? We're going to make him the root. So spanning tree MST instance number 4, root primary. So now he's going to be the root bridge for MST instance number 4. So he is instance number 1's root. Let's do that. Let's pick this guy. Instance number 1's root. Instance number 2's root. Instance number, who's that? Let's say list 2. Use 4. Instance number 4's root bridge, and instance number 3's root bridge is right there. Right? So we got different root bridges for all these guys. That's just the way to optimize the network. That's how they kind of built it in this book, at least. So, where were we at? I believe that was it for task 5. Final task. Now this, I did not know. I didn't know what the hell they were talking about here. I might have to do a deeper dive on this one, maybe a little bit of reading after this stream right here. But task number 6, there's only one command, so we pretty much wrapped it up here. But task number 6 was configure spanning tree so that interface cost values appear to the 802.1t long version. I didn't know what the hell that means, and I didn't know what the hell it was even asking for. So I had to definitely go to the solution guide for this book, for this task right here, because I need to definitely, like I said, multiple spanning tree is one of those topics and stuff that I haven't reviewed and touched in a long ass time. So I need to do some further reading on this right here. What they said here was for that specific. So we like, y'all know in algebra class, you had to look in the back of the book to get the answers and shit, right? That's definitely what I had to do here. So by default, the 802.1d, which I believe is classic spanning tree, if I'm not mistaken or not. No, I'm not classic, MST. Specification assigns a 16-bit short default port cost values to each port that is based on the bandwidth. Again, by default, 802.1d, spanning tree, specification assigns a 16-bit short default port cost values to each port that is based on the bandwidth. What are my bandwidths, or my port bandwidths? Well, if you've been watching, paying attention here, you'll notice I've been playing with fast Ethernet. So what's that? That's 100 megabits per second, right? Not 1,000, yeah, 100 megabits per second. So we do a show span, what the hell, SP, span, right? Show span, let's just do MST, right? And we'll see, these are the port costs that they were talking about, right? Path costs, rather. These are the costs right here. So the default port cost values to each port is based on the bandwidth. Well, the bandwidth on these are fast Ethernet, so that's what, 100 megabits per second. How do they come up with that? The 802.1t formula standard assigns a 32-bit long default ports cost values to each port using a formula that is based on the bandwidth of the port. So bandwidth of the port, again, is 100 megabits per second in my case, right? The formula for obtaining default 32-bit is to divide the bandwidth of the port by, that's not 200,000, that's what, 200 million, I guess? Yeah, 200 million. So I got to divide, what, the bandwidth of, I don't feel like doing any damn math. There's, like I said, there's one command and it does it for you automatically. But the fast Ethernet ports, divide that by 200 million in this case. To complete this task, you will need to change the default 802.1d cost method as follows. And it was just, like I said, just one global command. You got to do this on each switch. So, but we can verify it with what? See what the default cost method, the current cost method. Show spanning tree path cost. What else is it? Method. This is the default path cost calculation method. Again, it said the cost was that. Right? I think that is the short version. They want us to configure it to be the long version. Short is 16-bit, long version is 32-bit. I know it sounds confusing and stuff, but that's exactly what they said here. And I'm trying to explain it as best as I can. But notice it says 100 there. And also, we do a show spanning tree path cost calculation or path cost method. Right there. Says right now the spanning tree default path cost method is short. They want us to change it to long. Operational value is long. So let's change that. Right now it is short. Again, this is a global config, a global command, so it's not like you got to do it on specific instances or anything like that. It's just done on the whole switch for you. So we do a show. Let's take a look at what our costs and stuff are when we do this at the beginning, before we do this, what it's showing as. It left that as 100,000. What other path costs do I want to see? Where else can we see that? Show spanning tree. Let's do a show. Let's look at the config. No, show spanning tree. Let's do show spanning tree. Let's just do that. Do show spanning. We're almost done, y'all. We're almost done, y'all. MSC 0 is that. And notice all of these costs are showing 100,000. So basically, what did they do? They did 100,000. What is the formula for the other one? We don't have this formula for the short version. But it says assign a 16-bit short default path cost values to each port. 802.1t assigns the 32-bit default port cost values. Okay, so let's see here. MST is a real bitch as you get into it. Yes, tell me about it, man. Particularly in terms of path manipulation. The basics are fine, but as soon as you start to do things like MST, rapid, PBST, internet networking, starts to get complex fast. Exactly, and that's exactly what I was explaining to y'all, man. Like, spanning tree is one of those set it and forget it, because it's like almost like plug and play. You can optimize your network and stuff like that by picking specific root ports, and picking specific root switches, and just modifying your spanning tree topology. But like he said, shit can get really complex. Like he said, really fast, because it's just your head would just start spinning, just like what I was saying, man. That's exactly what I said. There's two formulas for path costs, the old one and the new one. Wow, I didn't know you could use both of those. That's cool to know. Looks like I have a long ride ahead. Hey, so do I, man. Yeah, that's what the bound, STP, is that in the picture. It is a boundary port for the region. And our PVST switches don't participate in the region. That's where you get into more complex path manipulation mechanisms. We got Geek Master in the building. Appreciate you for tuning in, man. I need to get a curl sponge, man. Yeah, I definitely need to get a curl sponge. Let me try that. Curl sponge or some curl girl gel, man. Don't mind my bonnet, y'all. I know I said that a bunch of times, but trying to pray these curls, man. I'm growing out my hair, y'all. So, just like you mentioned, man, it can get real confusing real fast and stuff like that. So just know that there is some formulas. Let's go ahead and just change the mode of when it span tree mode. No, what was it? Span tree MST path cost, right? No, span tree. What was it? What the hell? I just did it, man. I was just up there. Path cost, yes. Why the hell is not doing it? Path, because you ain't type that. Method, the long one. So you can do either long or short. Like I said, long uses the 32-bit base values for default port path costs. Short uses 16 base values. They wanted us to do long. Log. We got to do that. This is a global command. You got to do this on all four switches. Let's see, what did it change the path cost to? Does it change the display or or whatever. Let's see. So span MST. Let's just do that and see what we got. Where can you see the default port path? Where can you see the path cost change? It's still showing 100K. I want to see where it is. Was it this? Was it that right there? No, I don't think that was that. That was always like that. Internal costs. Yeah, man. Spanning tree. We know spanning tree was already a deep subject, but once you get an MST, you're grouping these instances, VLANs into different instances and stuff like that. It starts picking different ports, and it can just get really complex, man. And if, like I said, like I was saying earlier, I can start drawing. Okay, which one's the root port, and tell you which one is blocking and stuff like that. It can get real confusing, and this shit'll look like a damn squiggly, just squiggly annotations and stuff, man. So it can get real confusing. MST only works with long path costs. Your PBSTs are where you have an option. It's telling you that the short version is administratively configured, but MST will only operate with long. Okay, good. Thought you were making a fashion statement. Nah, man. Like I was saying at the beginning of the stream, man. Yeah, so I'm trying to protect these curls, man, growing out my hair and stuff like that, man. And you know, if you know, a lot of people, especially in the African American community, we're getting criticized for wearing our bonnets in public. So I'm just kind of like, this is kind of like I'm doing this in what do I want to say? What's the word I'm trying to say? I can't even remember the word. I need to wrap this up. Anyway, but it's like I stand with them, man. So I'm like, man, fuck it. I'm gonna wear my bonnet on my stream. Who cares? I'm trying to protect my hair, man. I wouldn't do this in public, but it is what it is. So configuring spanning tree path cost method long did absolutely nothing for MST. Okay, it would really only be useful if you're trying to work PVST into it. Okay, good to know. So I guess this just kind of changes the method, but it didn't do anything like he said. So let's just do that and call it a night. I think that's pretty much it, right? Long on this one. Long. I may need to do a custom lab and just start playing with it. But like I said, man, spanning tree can get real complex real fast. And then if we start doing show, span, MST, and try to figure out which ones are blocking and which one's the root port and all this other stuff, man, it can get real confusing fast. As you can see just by looking at these show commands and stuff like that. We just know that the shit works, man. Besides, they designed it for us, right? We got a blocking port, we got a forwarding port. Who is this guy? ALS1, so he should be the root bridge for MST3. So MST3, that is why he has the lower root bridge for that specific instance right there. And I think that's pretty much it, man. Is there any other show commands y'all need to run to verify our work and stuff? Let's look at I'm gonna look at the solution guide. We pretty much wrapped it up. Appreciate you guys for tuning in. Shout out to Kelvin, Tram, Geekmaster, Juan. Appreciate you for tuning in, all you guys. Next lab will be, I'm gonna try to stream tomorrow too. I know I said I'm gonna try to do, we typically stream Monday through Thursday, 8 p.m. Eastern Standard Time, but I have been inconsistent, such as I just been inconsistent lately, man. But it is all what it is. I'm trying to do some more reading and stuff, man. Trying to educate myself more before I start streaming and stuff on these topics. Let's see, what were we missing here? I'm gonna see how they did it, configured it. We did the channel configuration. We already did the show spanning tree summary to verify show span summary, verify which error disabled modes we have configured. Right now we have EtherChannel misconfiguration guard. This is enabled by default, I believe, if I'm not mistaken. We have 5 MST instances. We see which ports are blocking, etc., etc., which ones are forwarding. What else we want to run here? We could also see what show error disable recovery interval. Just recovery, and then it'll show us the interval at the bottom. That lets us know after 5 minutes when a port, or after 10 minutes when a port is error disabled, it'll bring it back up. Nothing at the next time out there. What else we want to cover? We already know all of our ports are trunking, right? We verified all our work, right? Show interface is trunk. This is just ALS1. I'm not gonna verify all of them, but we have all of our VLANs there. This side became a trunk because it negotiated. That's why the N is there. It is 802.1q. These guys are being forwarded and on port channel 4. So we have port channel 4 and ALS1. ALS1, port channel 4, I believe, if I'm not mistaken, is here. So I believe this is port channel 4. Ports 9 and 10, right? If I'm not mistaken. And it is forwarding all those VLANs, or those are the ones that are allowed. We didn't do any pruning or anything. Port channel 2 is only 1, 2, and 5, and 600. I guess some of those other ones were left out because of spanning tree. So you see, sometimes like you don't know which one's supposed to be blocking or not until you run these show commands for spanning tree. See when, so you'll figure out why those other like 700 and 800 is not forwarding on port channel 2. So on port channel 2 right here, 700 and 800 is being blocked or not being coming across these ports right here, or port channel 3, I think that is, right? Is that port channel? No, it's port channel 2. That's port channel 2. This right here is port channel 2, I believe, and I believe this is 4 right there, if I'm not mistaken. We verify that, right? So EtherChannel summary. Let's connect the dots here, right? Port channel 2 is 7 and 8, right? Port channel 2, yep, 7 and 8. Any other show commands y'all want me to run to verify, to see, kind of help us understand this lab and stuff more? We pretty much wrapped it up. That was task number 8. Y'all make sure y'all join that Discord server. Let me get a copy here. And again, let's see. I'll try to get on for the next one. Yeah, appreciate you for tuning in, man. That is the Discord server if y'all want to join. If I cancel a stream, I'll let you guys know in that Discord server. I also have my study guide there. That is a spreadsheet that we are going to be covering a lot of topics. So today we covered this lab right over here, lab number 3. So we're going to try to do a lot of MST this week. So I'm going to try to do maybe this or this one tomorrow. I don't know. We'll see. I'll see. It depends on if I got downtime at work to do some training and if I have enough time to cover it and stuff like that. But if you want to copy this, make sure you join that Discord server. It is free. Go ahead and see if you can cover chapters 2 and 4 on your own time. Go ahead and cover those. That's what we're going to try to do. I'm going to try to go over these videos, some of these YouTube videos right here. And yeah, that's pretty much it, man. For now, comment, like, subscribe to the network. I'm going to call myself Network Bonnet.